Here is on derivatives. Now we know that how to find a derivative at this point, right? If we're given f of x equals x squared, we know how to find the derivative. F prime would be 2x. Um, but what happens if we are given just a function, right? So actually, it's kind of hard to see my function here, but it's this brighter. Let me change my settings here. Change it to projector mode. So there we go. You can kind of see it. It's underneath this black dotted line, okay? And what this graph is, so this is my function, f, that we were not defined, okay? I mean, it's here, but we don't have an equation for it. And this up here, this orange dot, is the derivative at that point. So this is like the graph of the derivative. It's tracing it out. So basically, if when I'm here at this point, which looks like maybe negative 17 something, right? Then it looks like my derivative here is, okay, so I'm at negative 17.4, it's 3, okay? And so this point is going to change, right? This point here is going to change as I slide this around, okay? And so it's going to give me the same x value as my point. It's just giving me the derivative at that point. And you notice, right, that as I'm sliding across my f here, that my derivative seems to not be going anywhere, right? It's staying right on this line here, which looks like y equals 3. And you might think, well, why is that happening? Well, because if you look at this picture, what kind of graph is this? It's a straight line, so it's a linear graph, right? So it must have my function must be something like y equals 3x something, right? Because the slope here is always 3. So when I'm dealing with the derivative of a line like this, right, then my derivative is constant because the derivative is the rate of change. And in this case, when I have a constant, slope of a linear function, it doesn't change. So actually, I'll show you what I have here. Okay, so I have y equals 3x minus 6 is what my actual function is. But my derivative, right, if I think of what f prime would be, it'll always be x equals 3. Or, I mean, f prime will always be 3. So actually, let me put the graph of g on here. Actually, maybe I can put the graph of g on here. Right, so g is the dotted line. So that is the derivative of f. And so as I trace out, now let me close that back up. As I trace this back out, then you can see my derivative just it goes in a straight line because the derivative of my linear equation is always the same. Okay, so let's look at a different one here. All right, so now it looks like what I have here. It kind of looks like a quadratic function of some sort, right? It's opening at the top in both directions, and it's got the low peak. I don't see anything else where it's coming down, so I'm kind of thinking it looks quadratic to me. And again, here is my point, right? And so basically this dotted line, it was hard to see in the linear one, but it's really the tangent line, right? So as I slide this around here, right, it's going to trace out my derivative. Okay, so here I'm at point 10, negative 10, 138, and down here at that place, my slope is negative 24. Okay, so my graph is definitely going downwards, right? So as my graph is decreasing, my slope is negative. Okay, so as I trace along here, right, as I come down here, if you watch the slope, right, we say it's got steeper slope when my graph, when the, like this dotted line would become more vertical like this, right? But when as it's slanted like this, it's definitely negative. And as it becomes more sort of horizontal, we call that less negative. So as I'm sliding my point down here, my tangent line is actually becoming slightly more horizontal, right? It's starting to sort of turn. And so as I'm doing that, the slope of my tangent line is decreasing, right? Or it's actually increasing is what it's doing because it was up here, negative 24, right? And down here, it is now negative 20, right? So my slope of my tangent line is actually getting larger in this particular case, okay? So as I slide down and I see that my graph is, now kind of watch how this is tracing out. my graph is coming down here, right? And it's become less and less negative, so I'm getting closer and closer. Let me zoom in here a little bit more so you can see. So as I get closer and close, as this becomes more horizontal, but still negative, as long as it's downward, we think, in terms of slope, it's negative. My tangent line, the dotted line here, and so my point is underneath the x-axis for my derivative because my derivative is the slope at that point. And so here, my slope is now negative 15, but as I drag it closer, it's starting to shrink, right? Because I keep getting, my graph is going more and more sort of horizontal and less vertical. And as I slide along here, it becomes less and less and less, right? Vertical and more horizontal until, right? Until where? Let's see, right? At the bottom here. Well, I'm still a little bit negative right there, right? As I slide over, eventually I'm going to, hopefully I can get there, hit 0, okay? So right at the bottom, right? Right at the bottom of my sort of smooth curve here, my tangent line ends up being, it's 0. So if I think about where that point is here, right? It's actually when I see this point where I'm going to get a horizontal tangent line, my derivative is actually 0 there. So that's one way we can kind of think in terms of how do we graph this if we just know what f is, or how do we pick the graph of f prime, okay? So, right, so back here, if I look, my slope was negative and my point is below the x-axis, okay? Because my slope is negative here. And then I get right here to the bottom here, and here is where my slope is 0, and my, right, so my tangent line is horizontal, and I'm going to have basically an x-intercept here where my graph goes where f goes, right, gets this nice smooth curve to it, and my tangent line is horizontal, I get an x-intercept on my derivative, okay? So now this way, now my tangent line starts to become positive. I'm sliding it along, my slope is getting bigger and bigger, I'm becoming more vertical, bigger, 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 right? I'm almost on top of the other point. Let me unclick this, right? So now, one thing you may notice is that that point seems to be kind of traveling along on a straight path. And so that's kind of another way that we can think of this can help us in our graphing of derivative. Like if this is a quadratic function, then when we take the derivative of a quadratic function, you're going to have something like, if it's plane x squared, you're going to have 2x. Well, 2x is a linear function, right? So if I put on here, I'll show you the graph of the derivative. So actually we were graphing, this was our original function here. I didn't want you to see it at first. And then my g, this is the graph of the derivative, right, is the orange line. So if you kind of think, right, that if I have a second degree polynomial and I take the derivative, I'm going to have a first degree polynomial, which is linear. So as I trace out the derivative here, right, that orange line just slides across. My slider only goes from 10 to negative 10. Okay, so let me slide it back, right, as I go. See how the orange line is sliding right along the dotted line. That dotted line is my derivative, okay? All right, so things to watch for is places where we have high and lows. My derivative is going to be 0. And when I have a negative tangent lines, right, where it looks like my graph is falling, my graph of my derivative will be underneath the x-axis, right? If I slide it over here, see how and then, right, I'm going to hit 0 when it's flat, and then I'm going to be positive when I'm up above the x-axis. Okay, so let's get a little bit more complicated. All right, so this time I have a little more something complicated, right? So this time I'm not really seeing my orange dot to start with. There it is. It's way up here because my graph right here is very positive, right? It's very almost, it's just slightly less than vertical. So up here it says that the slope at that point is 15, right? At negative 2.53 approximately. So then as I come here, right, my line is starting to become more horizontal, so my derivative is getting smaller, right? Smaller slope means more horizontal, and then I'm going to hit, right? Notice I'm going to the top of my graph here. If I can make it go horizontal, right, my derivative is going to have this point on it right here. Now, I'm slightly off here, but you can kind of see I'm right around 0. All right, so then I'm going to, now my graph is sloping down, so my slope will be negative, so you'll watch my point, it'll go underneath the graph, right? And it'll keep going, right, as my kind of estimating my slope is not terribly steep right here. And then it'll become 0 again right here. Oops, I just slid right past it. Okay, so I can maybe move this over a little bit. Okay, well, somewhere in here, I can almost get it, which I'm sliding it the wrong way. But somewhere in here, you can kind of see the point crossover. When my graph goes perfectly horizontal, when my tangent line becomes perfectly horizontal, then that's where I'm going to cross. So basically, I can kind of see I'm going to cross right here. And then my upward slope says I'm positive, and as I get up here, my slopes will be even more positive, so my graph will be very vertical, right? So I'm going to slide it up, and as I do, it's kind of like if you took a ruler and slid it across a line. That's what your tangent lines are doing. So this is just calculating the slope there. I've got it sort of set up so it calculates the slope along, and it's kind of tracing it out, okay? So from this picture, right, I know that my derivative is going to basically hit 0 here and here, and then it should be above the x-axis here because my slope here is positive. It'll be below here because it's sloping down. It'll hit 0 here, and then it'll be sloping up. So let's put our graph of the derivative on there. And, oops. Okay. There it is. Okay. So again, if you think in terms of degree, my function, right, it rises from the right and then does this thing and then it falls to the left, which means it's probably an odd degree polynomial. And since it doesn't have a whole lot of loops, I'm going to say that it's probably a cubic polynomial. Actually, you can see the function there now, can't you? So it's a cubic polynomial, so I know that my derivative, right, of x cubed is going to be something x squared. In this case, the first part would be 3x squared. So my graph of my derivative should look like a quadratic. And if I close that back up again, right, so as my derivative, or actually as my function becomes like the tangent line becomes flattened right here, that's where my x-intercepts are going to be on my derivative. So that should be here and right around there, right? So that one is also horizontal. You notice this is down sweeping before that, right? So here's my graph. So that means, or actually, I'm sorry, we're looking at the red one is the f and the dotted one is the derivative. So as this one is going upward, my graph is positive up here, right? And then once I hit this place right here, I hit the 0, and then my graph is going negative, so it stays below the x-axis. And then here, I hit 0 over here, right? So that's going to give me another x-intercept of my derivative, and then it's going to go up. So all these tools can kind of help you think of what would the derivative look like if I only had the picture. All right, so one more. So we'll get a little bit more complicated with each one. Oh, I'm showing you what it is. Well, I don't have it in a good form, so you can't really tell. Okay, so this one, maybe you can tell, it looks like it's both ends are pointing upward, so that means it's an even polynomial, right? So it's x to the fourth is technically what it is. Now for this one, actually I don't know why I zoom back in, I'm gonna have to, so if you notice, like right here along the graph, it's very negative, right? My slope is almost downward vertical. So like my derivative is way down here, right, at negative 256, right? So this corresponds with the point 3 or negative 3, and then this is the derivative at negative 3 is negative 256. So let me zoom in a little bit more so we can see it better. My point will come back into view, but I'm very vertical, so my derivative is very negative, so it's way down there. Well, I can't move my point now, okay? Actually, I can just make it automate, okay? So as I go down, right? Oop, that was really fast. Actually, let me slow it down. Maybe I can slow it down. Of course, I have to get in. Oop. All right, so I'm going to step now. I'm going to change my speed here. Okay, well, never mind. Okay. So I'll stop it. That's there. Now it's sliding. Okay, so I know that when I come over here, my slope is very negative. So my point is way down there, right? As I'm sliding down, it's becoming, well, it's still pretty negative right there, but it's becoming less negative because my tangent line is having, well, it's still, let me move this down a little farther. So now I'm starting to become slightly less vertical. I don't know why my point is just not wanting to slide for me. Okay. There we go. Okay. So as I come down here, my slope is getting a little less, but it's still negative, so my still below. Then right about somewhere here, if I can get there real quick, I'm going to hit a 0, right around there. And then I'm going to come back up here again. That was a little positive loop, right? So it went up a little bit. And now I'm at 0 again. And now down here at this bottom, I'm also going to hit 0 again. My graph is sloping downward, so my graph's going to go below the x-axis, right? And then I'm going to hit 0 again. Right in there somewhere. And then I'm going to get super positive on the end, okay? So again, right, now you can't really tell from this graph, but it is x to the fourth. And so the derivative of an x to the fourth graph would look like an x cubed graph, right? So if I want to put that on there, right, I got a lot of dotted lines on here. The red is the original function. The black is the tangent line, right? And as I trace out the tangent line, the orange point slides along the derivative. So that's what the derivative actually looks like. Now, if I didn't know that, right, I would look at this function. I would say, oh, it's very negative here, so I know it's going to be down here somewhere. I know I'm going to have a 0 here. I'm going to have a 0 here. I'm going to have a 0 here because those are all, you know, tops and bottoms of my high points that are nice and smooth. And then my graph is going to go very positive here. It should be a little bit positive right in this little part, little negative here, okay? And it is, okay? So that's kind of how we can figure out what the derivative looks like without actually having the equation.